In this course, we're going to make use of right triangle trigonometry. You may have learned this in a prior math course. However, there are prereqs for this course that allows you to get here without having had any trigonometry, which is why I'm going to go over it now. So I have drawn here a right triangle. The first part of right triangle trigonometry that I'm going to go over is called Pythagorean's theorem. Pythagorean's theorem states that a squared plus b squared equals c squared, where a and b are two sides of the triangle, but c must always be the hypotenuse of the triangle. So in my triangle over here, I could flip a and b, and Pythagorean's theorem would still hold true. However, I have to have c be the hypotenuse, or else the Pythagorean's theorem calculation will not work out. And this is useful when you have two sides of the triangle, or you have the hypotenuse on one side and need to find the other side. So it's useful when you're working solely with the sides of the triangle. Now we're going to discuss how we're going to engage with the angles. So I have two angles drawn here. This angle here I'm going to call phi. Phi is a Greek letter often used to represent angles, and the other angle, interior angle, I'm going to represent with theta. Theta is a very common Greek letter used to represent angles in physics courses. Cosine of an angle is equal to adjacent over hypotenuse. So for the angle theta, the adjacent side would be b and the hypotenuse is c. However, if we want to do the cosine of phi, the adjacent side would be a and the hypotenuse would still be c. The definition of cosine means that we're not using always the same side divided by the hypotenuse. It depends upon what angle you're using inside the cosine function. Sine is going to be very similar, so the sine of theta is going to equal opposite over hypotenuse, which for phi is going to be a over c, since a is the opposite side to theta. The sine of phi is going to be the opposite. It's going to be b over c, because the side opposite to phi is b. Our last trig function is going to be tangent. Tangent is equal to opposite over adjacent. So this one does not involve the hypotenuse. So if we're looking at theta, the tangent of theta is going to equal the opposite side, which is a, over the adjacent side, which is b. But the tangent of phi is going to equal b over a, because b is opposite and a is adjacent. Now keep in mind, with these relationships, we're not going to actually be solving for the cosine of an angle or the sine of an angle or tangent of an angle. That's something we would very rarely do. Most likely we would rearrange these relationships to either solve for one of the sides or the hypotenuse of the triangle. So the way the definition is stated for cosine, sine, and tangent is not the way we actually use that equation. Now, what happens if we're given information about the size of the triangle and we want to know what one of the interior angles is? We are going to use something called an inverse trig function. Now, an inverse trig function does not mean 1 divided by a trig function. It is a special button on your calculator. Most of the time you have to hit the second or shift key and then the cosine, sine, or tangent button. And it makes use of the same definition. So the angle theta would equal the inverse cosine of adjacent over hypotenuse, which would be b over c. And for phi, the inverse cosine of a over c would equal phi. When we go to use sine, once again we're going to use opposite over hypotenuse. So the opposite of theta would be a, and the hypotenuse is still c. And for phi, we would then use b over c. And our last trig function is tangent. So for theta, the inverse tangent is going to equal opposite over adjacent. So for theta, opposite is a and adjacent is b. And then for phi, the inverse tangent of opposite over adjacent, so opposite is b and adjacent is a. And once again, you'll use these relationships when you have the sides or the hypotenuse of the triangle and you want to find one of the interior angles.